Good evening. Good evening. Good evening. Good evening, Srigandha. Good evening. Good evening, Tejal. Good evening. Okay. Good evening, Ashi. Tejal, leave a message. Class has started. Need to join immediately. Yeah. And tomorrow onwards, no need to send that message also. It is their responsibility to join. Only today you have to send the message. Right? Morning we are discussing about irrationality proof. I want to tell it again once again. But I am taking a different number, root 5. We need to prove that root 5 is an irrational number. Okay. So as I told you that I use, to solve this problem, I use method of contradiction. Method of contradiction is the one, in the beginning we will take whatever we have to prove, contrary to that we will take another. Suppose we need to prove root 5 is irrational. Contrary to that we will take it as, let us assume root 5 is a rational number. It is a rational number. Okay. Where a and b are integers, b is not equal to 0, and highest common factor of a comma b means is 1. Highest common factor for a and b is 1 means there is no common factor for a and b other than 1. This is what we have to consider. I am going to solve this problem by using method of contradiction. Method of contradiction, and I told you already that generally children used to think that we can get good score if we read for the exams before 2 months of the commencement of the exams. They will feel like that, and the remaining months they will try to enjoy maximum. And when they start reading or when they start studying 2 months before examination, they can come to know that yes, we need to study from the beginning. Whatever we thought is wrong, Whatever the parent says or whatever the teacher says is right only. Okay, that is what method of contradiction. So here also we need to prove root 5 is irrational, but we are assuming it as a rational number with certain conditions. We are assuming root 5 is a rational number with certain conditions. What are the conditions? A and B are integers, that is already known to us. B is not equal to 0, definition of rational number. But this is a special condition that highest common factor for A and B is 1. Okay now? Now, what I will do is, I will square it on both sides. So what is remaining? 5 is equal to A square by B square. 5 is equal to A square by B square. Then if you simplify this, what will you get? 5B square is equal to A square. I told you, this is the heart of the problem. This step is heart of the problem. And this is also very, very important. Right? Highest common factor for A and B is 1. That is also very, very important. Now, if you try to understand about this step, you can clearly say that 5 is a factor of A square. You can clearly say that, or you can clearly understand that 5 is a factor of A square. As I told you that 5 is a factor of A square, then 5 is a factor of A also. Let it be 1. 5 is a factor of A. Okay, children. Now, think about this step. 5 is a factor of A. Then, surely A is a multiple of 5. I will give an example. 3 is a factor of 12. 3 is a factor of 12. Then automatically 12 is a factor of 3. 12 is a multiple of 3. Okay, children? One more example. 4 is factor of 24. 4 is a factor of 24. Then we can say that 24 is a multiple of 4. In the same way, 5 is a factor of A. 5 is a factor of A. Then A is a multiple of 5. Then we can express A as some 5x. Okay? Now, try to insert this in this equation. Try to insert the value of A in this equation. 5b square is equal to 5x whole square. 5b square is equal to 5x whole square. Now, 5b square is equal to 25x square. 5b square is equal to 25x square. Divide throughout LHS and RHS in 5, what you will get? B square is equal to 5x square. Think about this step. B square is equal to 5x square. Think about this step, children.
Yes.
B square is equal to 5x square means 5 is a factor of B square. 5 is a factor of B square. Then 5 is a factor of B also. Let it be 2. Now observe 1. 5 is a factor of A. Observe 2. 5 is a factor of B. That means from 1 and 2, 5 is a common factor of A and B. It is a common factor of A and B. Okay, children? But what we have taken here? A and B both are not factors other than 1. A and B both are not having common factors other than 1. But what we got? 5 is a common factor of A and B. 5 is a common factor of A and B. What is the meaning of that? What is the meaning of that? Whatever we have taken in the beginning, quite opposite we got the answer. Why this situation arises? This situation arises due to our incorrect assumption is that root 5 is a rational number. So root 5 is not a rational number, it is an irrational number. Okay? Now as I told you children, this problem is very important for board exams. Okay, it is very important. Now see in what way the questions will be. In what way the questions will be. See, I will read out one question here. Prove that 5 plus 3 root 2 5 plus 3 root 2 is an irrational number. Prove that 5 plus 3 root 2 is an irrational number. Okay. It is being given that root 2 is irrational. Given that root 2 is irrational, take it granted. Root 2 is irrational. Take it granted. But we have to prove that required to prove is 5 plus 3 root 2 is irrational. Children, this is a 2 marks question. Sometimes it will be given to you for 3 marks also. Generally, it is a 2 marks question, children, but sometimes the board may ask this question for 3 marks also. Okay, na? How to do this? Here, remember, no need to prove that root 2 is irrational over here. It is given. Here, no need to prove that root 2 is irrational because it is given. But what we have to prove? We have to prove that 5 plus 3 root 2 is an irrational number. Then here also children, we'll go ahead with method of contradiction. Okay na? Let 5 plus 3 root 2 is a rational number. Let us assume 5 plus 3 root 2 is a rational number. Children, before solving this problem, we need to recall some properties of rational number. We need to call some properties of rational numbers. What are they? First property. If we add two rational numbers, the result is rational number. If we subtract two rational numbers, result is rational number only. If we multiply two rationals, result is rational. If we divide two rationals, result is rational. These are the 4 rules we need to recall. Once again, if we add two rational numbers, or if we subtract two rational numbers, or multiply two rational numbers, or divide two rational numbers, the result is rational only. This is what we have to recall. Okay. Now see here. 3 root 2 is equal to a by b. When we send 5 to that side, it becomes minus 5. Okay. Now, think about this one. A by b minus 5. A by B minus 5. A by B is rational, 5 is also rational, and we are subtracting two rational numbers, so the result is rational. That means A by B minus 5 is rational. Further you can simplify it. A minus 5B by B by taking LCM. By taking LCM, we can say that A by B minus 5 is same as A minus 5B by T. Okay. Now, so now what we got? 3 root 2 is equal to A minus 5B by B. Now, root 2 is equal to A minus 5B by 2B. Now, 3B, sorry, 3B. Now think about this number. A minus 5B by B is a rational number. Then A minus 5B by 3B is also a rational number. Because we are dividing a rational number with another rational number. So the result is automatically rational number. So this whole number is a rational number. This total number, this A minus 5B by 3B is a rational number. And what about root 2? What about root 2? It is given that root 2 is irrational. It is given that root 2 is irrational. Can a rational and irrational, or can we say that they are equal? Can we say that they are equal? No. A root 2 cannot be equal to a rational number. So, this situation arises because of this. This situation arises because of this. What is this? 5 plus 3 root 2. 5 plus 3 root 2. Assuming 5 plus 3 root 2 as rational, assuming 5 plus 3 root 2 as rational is wrong. So it is not a rational number, it is an irrational. Understood, children? Understood? Next. Yeah. Now, given root 7 is irrational. Given root 7 is irrational. Okay. Now what we have to prove? 3 plus root 7 by 5 is an irrational number. We have to prove that. 3 plus root 7 by 5 is irrational number. Given root 7 is an irrational number, we need to prove that 3 plus root 7 by 5 is also a irrational number. Okay? Again we'll start with the method of contradiction. Method of contradiction. What is that? Let 3 plus root 7 by 5 is a rational number where d is not equal to 0. This step is must and should. B is not equal to 0 is must and should. Okay, na? Let us assume 3 plus root 7 by 5 is a rational number. Now, then what is 3 plus root 7? Then what is 3 plus root 7, children?
A by B minus 5
What is 3 plus root 7? Can anyone say? Let 3 plus root 7 by 5 is a rational number. Let it be A by B. Then what is 3 plus root 7? Now 3 plus root 7 is A by B into 5, which is 5A by B. 3 plus root 7 is equal to A by B into 5, which is 5A by B. Which is 5A by B. Okay then? Now, so 3 plus root 7 is 5A by B. Now, then what is root 7, children? What is root 7? What is root 7? Yes, very good. 5A by B minus 3. When you simplify it, what we will get? 5A minus 3B by B. 5A minus 3B by B. Okay, na? Now you tell me, what is 5A minus 3B by B? What is this? What is 5A minus 3B by B? Rational number. This is a rational number. Then what is root 7? Then what is root 7? Yes. What is root 7? Root 7 rational, huh? Irrational. Root 7 is irrational. So automatically what will happen? Root 7 is not equal to 5A minus 3B by B. 5A minus 3B by B. Okay. So this situation arises because of this one, this statement. Assuming 3 plus 7, assuming 3 plus root 7 by 5, a rational number, as a rational number, is wrong. So it is not a rational number, it is an irrational number. Understand, children? Assuming 3 plus root 7 by 5 as a rational number is wrong. So it is not a rational number, it is an irrational number. Now, one more problem we'll see. Yeah.
Number 5 plus 3 root 5. 5 plus 3 root 5.
Yeah. Prove that root 2 plus root 3 is an irrational number. Prove that root 2 plus root 3 is an irrational number. We need to prove that. Okay. How to do this? It is not given that root 2 is irrational and root 3 is an irrational. It is not given. Okay. So what to do now? Yes. Let root 2 plus root 3 is a by b, where b is not equal to 0. We are considering contrary to that. The given statement is root 2 plus root 3. We have to prove it is irrational. But we are taking it as a contradiction. Means contrary to the given, or what we have to prove, we are taking contrary to that. So we are assuming that root 2 plus root 3 is a rational number, where b is not equal to 0. Okay. What I will do? What I will do here? Root 2 is equal to a by b minus root 3. Root 2 is equal to a by b minus root 3. Or now square it on both sides. 2 is equal to a by b minus root 3 whole square. A by b minus root 3 whole square. Now simplify. A square by b square plus 3 minus 2 root 3 into a by b. A square plus b square minus 2ab na? Now, if we do further simplification to bringing this number to this side, these two numbers, or we can do one thing. Take this 2 to that side and this whole negative number to this side. So 2 root 3 into a by b is equal to a square by b square plus 3 minus 2. Okay. Now, if we do further simplification, what we get here? A square by b square plus 1. Okay. And further we do that a square plus b square by b square. Now, root 3 is equal to a square plus b square by b square into 1 by 2 into b by a. This is what you will get. A square, if you take LCM here, you will get a square plus b square by b square. So a square plus b square by b square into this 2 will go to that side and become 1 by 2, and this a by b will go to that side, becomes, it get reversed, b by a. Now when you simplify this, 1 b get cancelled, so in total what we will get? Root 3 is equal to, numerator is a square plus b square and the denominator is 2ab. Denominator is 2ab. Now, children, you tell me what is a square plus b square by 2ab and what is root 3? What is a square plus b square by 2ab and what is root 3? A square plus b square by 2ab is rational number. Root 3 is an irrational number. And we know that now. We know that root 3 is irrational. So, a rational number, this is rational and this is irrational. Root 3 is an irrational number. So therefore, root 3 cannot be equal to a square plus b square by 2ab. So this situation arises because of assuming root 2 plus root 3 as an is a rational number. So it is not a rational number, it is an irrational number. Okay, now children. So these are some examples where you will get problems. Means, as I told you that this model is very important for board exams. It is very important for board exams. So I tried to explain some problems from that, and we will go ahead with the same. And tomorrow also we will see some real life applications basing on LCM and HCF of two numbers tomorrow. Okay, na? We will deal one or two problems like this on this model, and we will see real life examples basing on LCM and HCF of numbers tomorrow. Okay, children? So if you like this, click on like button, everyone, and you can leave the class. After clicking the like button, you can leave the class. Thank you. Thank you to all. Bye bye.